This is section 8.2. We're talking about scientific notation today. Many of you may have done scientific notation in science in some way, shape, or form. The goal of scientific notation is to write very large or very small numbers as a number times 10 to a power. Now the number has to be equal to 1 but less than 10. So between 1 and 10 really isn't written correctly, but we should probably say it's equal to or greater than 1 but less than 10. So remember, as we look at all of our scientific notation numbers, that number's got to be between 1 and 10 but not equal to 10. So our first problem has a little bit of a typo, so let's just change that big 3 to an exponent of 3. And so these are two examples of numbers written in scientific notation. If it's a positive exponent, you know that's a large number or a big number. If it's a negative exponent, you know it's a very small number with decimals. So let's look at each of these two next problems in example 1 and understand why or why not they're written in scientific notation. Well, let's examine first the number and then the base. Is this number between 1 and 10? No, it's not. So it's not between 1 and 10. So therefore, it's not scientific notation. Here's our second one. Once again, 0.5 is less than 1. So it's not scientific notation. Neither of these fit the case. So let's look down here at the bottom. How do we convert numbers into scientific notation? Well, all we need to do is move the decimal place over enough such that we're going to end up with a number, so we have our decimal point in between, making a number between 1 and 10. So this becomes 5.67. Well, how many times did we have to move the decimal over? All we need to do generally is just take the decimal from the starting point and count. Since we have commas in place, I'm going to count by 3's. 3, 6, 7, 8. This is a very large number, and so the exponent is going to be positive. We moved over 8 places, so it's times 10 to the 8th. Our number itself got smaller, so the exponent gets bigger. Let's look at part B. Our target decimal will be right here, in between the 5 and the 6. So we're going to write that as 5.6. And now we say once again, how many decimal places did we move? 1, 2, 3, 4, 5, 6, 7, 8, 9 decimals. So we moved it 9 decimals, and the question is it positive or negative? Well, the number got larger, so the exponent's going to get smaller. It always goes in a reverse direction. Let's look at our example C. Our target decimal is 3.5. The question is, times 10 to what power? Well, let's move our decimal over. 1, 2, 3. So that's 10 to the negative 3. Why negative? Well, the number got from a decimal to a larger number, so our exponent gets smaller to negative 3. Our last on this page, our target, as you can imagine, goes in between the 5 and the 3, becoming 5.3. Since we have our commas in place, we can say how many exponents are we going to have? Well, very simply, we've got 3, then 6, then 9, and then one more makes 10. Since the number here got smaller, the exponent gets bigger. In each case, we want to be careful that we're writing our numbers appropriately between 1 and 10.